Assalamualaikum and greetings to Puan Evina, Prof. Madya, Dr. Said, and also my fellow friends. This is Group T presentation on wheelchair and the analysis regarding the wheelchair. Our group consists of 4 members. The first member is Lenian Liovon 72304. The second member is Muhammad Nur Hidayat bin Jemat 72439. The third member is Leonard Anakjawan 72306, and the last one is me, Imanuddin bin Bujang 72266. Our presentation title is Smart Wheelchair Model T2020, and this presentation will be divided into 4 segments. The first segment will be handled by Lenian on Introduction and Methodology. The second segment will be handled by Leonard on Discussion and Conclusion. The third segment will be handled by Hidayat on Working Model and Analysis, and the last segment will be handled by me on Design and Concept. So let us move to our first segment with Lenian. Segment 1. Introduction and Methodology.
In homes of elderly and medical rehabilitation clinic, a nurse is requested to help patients walk daily. However, problem arises when the nurse is unable to accompany the patients while walking the other patient. Hence, in order to solve this problem, our group will design a smart electric wheelchair that can assist the patient's need when there is no nurse available. The smart electric wheelchair is using the principle between the transmitter and the receiver. There are some components that are vital in this principle, such as the antenna, radio frequency amplifier, tuner, detector, transducer, processor chip, and DC motor. Each of these components has its own function in order to produce work done to the wheelchair. The flow of the signal transmission is shown on the diagram. Antenna will capture the radio wave from the transmitter. It uses the concept of vibration of the wire. When the wire is exposed to the radio waves, it will induce a very small alternating current in the antenna. Next is the radio frequency amplifier, which is responsible for amplifying the weak radio frequency from the antenna so that the wave or signal can be processed by the tuner. Next is the tuner, which is responsible to extract frequency from mixed signals to different frequencies. The tuner is using a variable capacitor, which can have a function of varying the frequencies received. Next component in the wheelchair is the detector, which has a function of separating the audio information from the carrier wave. There are 2 types of signals, which are amplitude modulation and frequency modulation. The next component is a sensor which converts physical action to be measured into electrical equivalent and processes it so that the electrical signal can be easily sent and further processed. Next component is a processor chip that has a function of receiving input and providing appropriate output. Next is the transducer. The function of a transducer is to convert a signal in one form of energy to a signal in another. This process of converting energy is called transduction. Last component inside the wheelchair is the DC motor. The DC motor function converts electrical energy to mechanical energy and transfer it to the shaft of the sprockets. This is the framework of the methodology. We start with the problem analysis, then try to solve the problem with the suitable solution, and start our research in the design of our wheelchair. After that, the design process and the mechanical analysis is done. After the final prototype, we have a presentation and technical report is written. The design of the wheelchair is done by using AutoCAD Inventor, and simulation process is done by using working model software. The element mechanism used on the main wheel is 2 direct current DC motors, 2 sprockets in each wheel, and 2 chain drives to connect the sprockets. The motion transmission to wheels is made with chain transmissions. For the caster wheels, 2 small DC motors and 2 timing belt sprockets are used. These motors on the caster wheels allow the wheelchair to turn left or right. The electric wheelchair purpose is controlled by a remote controller. The ultrasonic proximity sensor attached to the backside of the wheelchair will detect the remote. Thus, the wheelchair will move according to the remote in certain sensing regions. Next, the LiDAR sensor attached on the front side of the wheelchair will detect any obstacles in the surrounding area. Let us move to the next segment with Leonard.
Segment 2. Discussion and conclusion.
So for my part, which is the discussion, calculation, and conclusion. First of all, we're going through the diagram of the gears. As you can see from the slide, we know that the input gear is the smaller one and the output gear is the larger gear. Before we can proceed to the calculation in order to find the torque output, the power output, the efficiency, the linear velocity output, first of all we need to determine the degree of freedom by using the formula of m equal to 3 in the bracket n minus 1 minus 2 jp minus j hash. After we substitute each of the components into the formula, we will get the degree of freedom is equal to 1, which also means it constraint mechanism. So this is a part of the calculation and the whole calculation is in the report. So first of all, the torque output is 93.836 Newton meter. The angular velocity is equal to 1.963 radian per second. The number of revolution is equal to 18.75 rpm. The power output is 184.247 watt. The linear velocity which is used by the wheelchair to move forward is equal to 0.1109 meter per second. The efficiency for the wheelchair is 73.7%. Why the percentage? Why the efficiency of the wheelchair is less than 100? This is because of two reasons in this report. First of all, heat energy loss through heat energy and friction. How is the motion of the wheelchair? First of all, the input gear is attached to the motor directly, so we assume from here the efficiency of the motor to the input gear is 100%. So started from motor, which rotate in counterclockwise rotation. The rotation motion will be transferred to the chain, and the chain will directly transfer the energy or the rotation to the output gear, and the result, the wheelchair will move forward. So basically this is the diagram for the mechanism. The input gear rotate in anti-clockwise, and so do the output gear will rotate in anti-clockwise because of the chain. So we did a safety measure in this project, which is the light detection ranging sensor, LIDAR. What it does, it fires rapid pulses of laser light at the surface, and its sensor measures the amount of time it takes for each pulse to bounce back. This indirectly will allow the wheelchair to move smoothly to ensure the safety of patient without crash into obstacles. So basically, the pulses are reflected to the wall and it reflected back to detector. So this is the mechanism for the LiDAR. So in conclusion, what we can conclude from this project. So in this project, we want the smoothness of the wheelchair movement, which is our main focus in the structure and mechanism. And in order for us to increase the efficiency, propulsion motor must run at a high angular speed. In order to change the motor speed to a lower speed and increase the available torque to wheel, motor with reduction gear and chain transmission were used. The virtual model for electronic wheelchair was designed by using working model software. The proposed solution used two DC motors controlled by the remote. There are two types of sensor used for the wheelchair, which are LiDAR, LiDAR sensor, and ultrasonic proximity sensor. This sensor help the wheelchair to move smoothly and ensure the patient safety. So that's all from me. Thank you.
Segment 3. Working model and analysis.
Thank you, Leonard. So now I will explain about the working model and the analysis of the wheelchair. So there are three simulations for our wheelchair in the working model, and they are the whole wheelchair movement, the chain drives mechanism and the steering mechanism. First, I will explain about the whole wheelchair movement in the working model. So in working model, the wheelchair shape is similar with the one in Inventor, but not 100% accurate, because the priority in this working model simulation is to analyze the mechanism of the wheelchair. So here, this orange colored part is the frame of the wheelchair, and these green circles are the wheels. For this part, in working model, we assume that the wheelchair is moving in a straight direction towards the nurse or patient. As we can see right now, the wheelchair is moving to the right at the desired speed of 0.69 meter per second. From the calculations, with the large wheel need to spin at the speed of 1.9 rad per second for the wheelchair to move at the desired speed. So for the next part, I will explain about the chain drives in working model. In working model, there are no chain drives or belt drives feature. However, we can still make a coupler relationship using gears to represent the chain drive. This is how the chain drive mechanism in working model assumed to look like. So this small green circle is the driver sprocket, which is connected to a DC motor, and it has 14 teeth. This large orange circle is the driven sprocket with 56 teeth and is connected to the wheel via a shaft to rotate the wheel. The angular velocity of the large sprocket is the same as the rotational speed of the wheels, which is 1.9 rad per second. To achieve this speed, this motor will need to rotate this driver sprocket at the speed of 7.85 rad per second. So in this case, we use a DC motor with the speed of 75 RPM. The chain drive mechanism is installed at both the left wheels and the right wheels of the wheelchair, and they will work synchronously to move the wheelchair. However, it can only move in one direction, which is the straight direction. This is the rotation. This is the details of the chain drive. So the roller chain we pick from the ANSI standard roller chain table, which is the chain number 25. Lastly, I'm going to explain about the steering mechanism. In working model, the steering mechanism of the wheelchair is viewed from top. Similar with the chain drive animation, we made a coupler relationship using gears to represent the belt drive. There are two animations in this, which is turning right and turning left. These two green rectangular shaped parts are the wheels front part of the wheelchair, which is viewed from the top, and they are responsible to steer the wheelchair. This upper animation is the wheel rotation to turn the wheelchair to the right, while this bottom animation is the rotation to turn the wheelchair to the left. This steering mechanism is using a belt drive. Each wheel, they are connected to a sprocket and a DC motor via a shaft. So the ratio of the sprocket will be 1:1, so that both the wheels will turn synchronously at the same speed. The turning speed to steer the wheels is 2.09 rad per second, and it is using a DC motor with the speed of 20 RPM. Also, they can turn clockwise and anti-clockwise according to which direction the wheelchair is supposed to go. Now let's move to the next segment with Imanuddin.
Segment 4, Design and Concept. Thank you, Hidayat, for the presentation. So let us move to our final segment on design and concept. Our design was inspired by the Charles Xavier wheelchair in X-Men series. So I'm using AutoCAD Inventor to design this wheelchair. So our idea is to integrate both conventional and also futuristic design into this wheelchair. The smart features in this wheelchair are the sensors, proximity, and also the LiDAR sensor, as been mentioned by my friend before. The second features is the variable speed. So the speed of this wheelchair depends on the power of the motor. So when the nurse want to increase the speed, it can be set. The signal can be sent to the programmer chip, and the programmer chip will be connected to the motor and increase the power of the motor and also the speed of the motor. And that is our concept idea for this wheelchair. Even though the speed in calculation is less than 0.5, it actually can be increased above 0.5 by the programmer chip. So this is the drawing for our wheelchair. This is bottom view, front view, top view, and side view, and also orthographic view. As you can see, the wheel is spread evenly to make it more stable, and the weight distribution is somewhere around this point. The reason why I make this because I want to lower the center of gravity and increase the stability. Our design also implement the symmetrical features also for the stability reason. These are the parts for the wheelchair. There are 21 parts altogether. The first one is the body frame, the green one, and also we also have the bearings, two on each side of the wheel, and also one on the front wheel, on each side of the front wheel. Three is the main DC motor set with the mounting, front DC motor, power and control box, the leg, back, bottom, front cushion, armrest, the main wheel, the roller chain sprocket, the V-belt, the groove pulley, the front wheel holder, front wheel, horizontal shaft, and also vertical shaft. This is the assembled view of the wheelchair. This is the mounting for the motor. This is the cushion. This is the power and control box. So the cushion, our idea for the cushion is that it can be detachable and can be cleaned separately. This the power transmission unit. It consists of power and control box, which inside of it contain batteries, processor chip, receiver, sensor, and antenna. There are two DC motors opposite to each other on the mounting, connected to the gear and also the chain. This is the bearings, as you can see. This is the front steering mechanism, consists of belt, pulleys, and also double mini DC motors. Even though the degree of freedom is 1, we decide to put 2 to increase the efficiencies of steering mechanism. This is the remote, consists of 3 buttons, which can be set separately. And this is our final design. So thank you and have a nice day.